What is a quadratic function? What does a graph of a quadratic function look like? And what are some examples of quadratic functions? To answer all of these questions, let's start by looking at the form of a quadratic function. A quadratic function is of this form. F of x equals ax squared plus bx plus c. Here a, b, and c are all real numbers, and a cannot be equal to 0. If you get a function of this form, you have a quadratic function. Now, since we're working with functions, saying f of x is just like saying y. So we can also write this like this. We have y equals ax squared plus bx plus c. So, if you have a function of either of these forms, you have a quadratic function. Now, there's something to note about quadratic functions. The highest degree that a variable can have in order to be a quadratic function is a 2. It has to be exactly 2. The highest degree for a variable cannot be lower than 2 and cannot be higher than 2. It must be exactly 2. So we need to make sure that we have that x squared in our function. And in addition to that, that x squared must be the highest degree for a variable in that function. So now we've seen the form for a quadratic function. Let's look at some graphs. Here's an example of a graph of a quadratic function. It looks like this: an upward-facing U, or an upward-facing parabola. A parabola is just the fancy name for a graph of a quadratic function. So here we have an upward-facing parabola. Now, here's another example of a graph of a quadratic function we can have. It's kind of like the flipped over version of this parabola. Here, instead of having an upward-facing parabola, we have a downward-facing parabola. Both of these graphs, or parabolas, are examples of graphs of quadratic functions. Now that we've seen some graphs of quadratic functions, let's look at some examples of functions that are quadratic functions and a few that aren't. First, let's start by looking at f of x equals x squared. Here, this is an example of a quadratic function. Now notice, we do not have an x term or a constant. Well, that's okay. We're just concerned about that x squared value. Here we have our x squared, and the highest degree for our variable is a 2, which means we have a quadratic function. Now let's take another example. F of x equals 3x squared plus 8x minus 5. Here again, we have another quadratic function. We have an x squared term, and the highest degree for that variable x is a 2. Here we have a degree of 2, and here a degree of 1. The highest degree that x has in this function is a 2. It must be exactly 2 to be a quadratic function, and since it is, we have a quadratic function. Now what about this one? X squared minus 6x. Here again we have our x squared term, and the highest degree that our x has is a 2. We have a degree of 2 here, and a degree of 1 here. So the highest degree is 2. We have another quadratic function. Now let's look at one more. F of x equals negative 4x squared plus 7. Here again, we have a quadratic function. We have our x squared term, and that too is the highest degree for an x in this function. Now notice, this x squared term is negative. We have a negative 4x squared. Well, that's okay. A negative in front of the x squared term just means that the graph of our quadratic function will look like this, a downward-facing parabola. So now we have some examples of functions that are quadratic functions. Next, let's look at a couple functions that are not quadratic functions. Let's see, f of x equals x to the third. Is this a quadratic function? Well, let's see, does it have an x squared term? No, it doesn't. It just has an x to the third. And if we look at the highest degree for an x value here, we have a 3. 3 is not 2. Remember, to be a quadratic function, the highest degree that your x value can have must be exactly 2. Here we have 3. That's too big. So this is not a quadratic function. Let's take another. F of x equals 8x minus 5. Again, we do not have a quadratic function. There is no x squared term in here. And if we look, the highest degree of an x is 1. 1 is not 2. We must have exactly the highest degree of 2. So we do not have a quadratic function. Let's take another. f of x equals x to the fourth minus 6x squared. Now this one's sort of tricky because there is an x squared term in here. But look at the highest degree for an x. 4. 4 is higher than 2, which means this is not a quadratic function. It has too high of a degree for x. Let's look at one more. f of x equals 7. Now this one's not even close to being a quadratic function. There's no x term in here at all. This, we're just looking at a line. It won't come close to looking like either one of these graphs. So now we have a few examples of functions that are quadratic functions and ones that are not quadratic functions. Remember, in order to be a quadratic function, your function must be of one of these forms. You must have this x squared term, and the highest degree that the variable x can have must be equal to 2.